Hi, and welcome to Mike Likes Robots, where we share knowledge to accelerate robotics. And today, we've managed to get to day 8 of Advent of Code. Today's puzzle is called Resonant Collinearity. So far, I've been able to keep one day to one video. That's not always going to keep happening. The days do get harder as they go, and at some point, I'm not going to be able to complete a puzzle within 1 hour or 1.5 hours if I push on a bit further. So let's take a read through this puzzle, see what's going on, and I'll cut to once I'm finished and I can explain it. Okay, this one actually took me quite a bit more time than usual to understand. I didn't understand that these are different frequencies in the puzzle. So we're given a map, our puzzle input, which contains one or more characters, the characters that aren't periods or full stops. So 0 is a frequency, A is another frequency. And we need to figure out all of the points on the map that are exactly in line with 2 antennae. So it does show an example at the bottom here. And I've already failed to understand it properly because I thought that because there's an A and an A, that it would create a line of antinodes that are in line with it, but apparently not. There's only one. So you only count one. So let's take these 2 zeros. So it goes down 2 and 1 over. So if we go down 2 and 1 over again, there's another antinode, as the puzzle is calling them. We can also do the same, but because it goes off the top of the map, we don't count it. Okay, so I think I understand it. I don't think it's too difficult to code based on my understanding. So let's give it a try and see how we get on. So I'll skip the usual project generation stuff. Okay, I've created the test text. I've got the cargo run. What I'm first going to do to try and solve this puzzle is actually create another test text that's much smaller so that I can play with it more. So for this, I'm going to take these lines and I'm going to remove this first set of dots. So ideally, I want something that has one antinode here, another antinode here, and a spare row to test that I'm not generating too many antinodes. So I'm going to take that and I'm going to write my first test around it. Okay, so I've got my first test. I know that there should be 2 antinodes, no more. So once I replace my do something function with actual code, this test should tell me if it works or not. So now I'm going to start actually trying to parse the puzzle input. I will use the name antenna map, struct antenna map. And I'm going to store this as a sequence of, or rather a list of points. I think that's the simplest way. Yes, that I think is the simplest way. Okay, so antennae, which will be a vector of point. What is a point? Well, we've already written the point structure, we've already created a separate crate for it. So all we need to do now is specify a dependency on it. So if I open up the code from, I'm gonna guess it was day 6, cargo.toml. Was it? It was. I'm going to take this line, put it here, and now I should be able to use util point. Actually, point. There we go. Now I have my points. Okay. Now I'm going to actually implement the from string for it. And this is the standard stuff. Derive debug on antenna map. Also create an enum class that we can use for errors. Currently empty. Type error is antenna map error. And function from str should return an antenna map. In fact, OK antenna map, where antenna is an empty vector for now. Let's rename this puzzle. And we're good to start parsing. All right, so the parsing should be fairly simple. If we get a dot, don't do anything. And if we get, actually, this is best stored as something else. So if we get something other than a dot, we want to store it as a vector of points in a hash map where the key is the frequency. So we're actually going to create a hash map here, which has a car as the key and vector of points as the value. We should import that. Good. Now that we can't have this, we need to do a hash map new. Great. Okay, so let's start building our list of antennae. It's a hash map new. And we're going to iterate over the puzzle lines. And then we're going to iterate over the characters in the line. In fact, we need to store the index to create the list of points. So let's do, this would be the row index. I'm going to rename this row so it matches. And then for column index and cell in row.cars. We should know what row is at this point, so I'm not sure why that's complaining. Because we need to enumerate it. Enumerate. And enumerate it here. Enumerate. Okay. This doesn't need to be mutable. I think if I plug it in there, now it is somewhat happy. All right, so let's match on the cell. If it is a dot, then we continue. And if it is anything else, then we insert it into the hash map. So I'll create a block for this to keep it contained. And I will antennae dot entry for the cell dot or default, and we'll give it an empty vector dot push the cell. No, we don't want to push the cell. We want to push a point onto the vector. Why don't you like that? Or default? Oh, right. I mean, the default will be a vec, but I like to be verbose. I'm going to do for insert vec. That's happier. However, it's the wrong type. So I need to create a point where the I just put round brackets, so that will be the row index and the column index. And I know it's confusing here storing y and then x, but as long as we keep the names, as long as we keep the order in mind, it does work. Okay. Point. And these are U sizes, so we need to convert them to I32s. And then that seems happy, so I will save that. Excellent. That is our puzzle parsed. I could print it out at this point to check it, but I think it's fairly simple. I'm going to move straight on with trying to solve it. So I am going to implement antenna map. We will have the function part A. And then this will return number of antinodes. So we need to take for each entry for key antennae, antennae, that's fine. And this is our frequency according to the map in self dot, we need to take a reference to self for part A to work in self dot antennae. And then frequency is a character. We actually don't need to know this character. We can just underscore it. We also want to keep track of the count. Okay. I think we could do with some idea of how big the map is. Unfortunately, we don't have that at the moment. So I am going to store that. The width will be a usize and the height will be a usize. And I may change these to I32s if it makes it easier to compare, because the data type here doesn't really matter, as long as it is some kind of integer that is within bounds. Okay, so with that in mind, we can't create an antenna map. We need to store our width and height. So we're going to do height is 0, let mute width is 0. And then our height is height.max of row index. -1? No, it won't ever iterate until it's past the row index. So that actually is fine. And then I can do the same thing here. Have it in. And change it to width. And now we give it the width and the height. Width and height. With that, we can create a inbounds function and self and a point that we're checking, which returns a bool. And it just says point.0 is less than self.width. And self.1 is less than, point.1 is less than self.height. These are signed, so we also need to check 0. Now, before I go on, I want to double check that. I didn't really think about it, I just wrote it one way around, so I'm going to check it now. So point.0 is the row, so it actually needs to be compared against the height. Also, have I checked? I think it is actually, it should be +1 on these, so it should be row index +1. Otherwise, we can have a height of 0, even though we've got a 1 wide array. Also, this should be col index, not row index. That's a good thing I caught that. Okay, with that, we are comparing I32s against usizes, so I will change this to an I32. And then when I store it, I need to convert it to an I32. That's it. As I32. Right, that should work. Yep, and now our comparison is happier. Good. Let's format everything. And then let's put it on one line. Okay, that's fine. Let's continue this. We can actually just borrow the antennae. We don't need to consume it. And so far happy. All right, so now for each of these antennae, we need to figure out where the antinodes are. So I want a list of diffs. Let's just construct it as we go. The list of diffs will be for each antenna, find the difference with every other antenna. So let's take our left point in, what I'm trying to do is left index left in the antennae in antennae dot iter. Do I need that? Dot enumerate. And then I need to put brackets around this. Perfect. Okay. Why are you? Yeah, we need type annotations. That's fine. I'll get to that. Okay, so now I have a point and I need to find all the points to the right of it so that I'm double iterating over. So for right index and right in antennae.iter.skip left index +1 dot enumerate. Actually, we don't need the right index. So we can get rid of enumerate and we can get rid of the right index. We only need the antenna itself. And then we're going to diffs.push left.diff right. Okay, now it really helps here that we're storing as I32s because it means that we can return a point with negative numbers in. But we also need to do some changes to our point class to be able to do this. So I'm going to open that up in a new VS Code. Going to take my point class and I'm going to create another public function, pub function diff. Going to take self and a point, reference to a point, and it will return another point. And it will simply be a point containing self.0 minus point.0, self.1 minus point.1. That's it. So is that what I want? If I have 0, 0 and I diff it with 1, 1, then my point should actually be 1, 1. So no, I want point.0 minus self.0. Point.0 minus self.0. That should be good. And then I can either make a subtract function, which is possibility, or I could invert the point, but I think I'm going to make a subtract function. So pub function subtract, I may just call it sub point, and point returns another point, and then it is this except with minuses instead. Okay, with those two new functions, I'll go back to my consistent puzzle here. Now diffs knows it's a vector of points, and we've created the diff. Perfect. So now that we've calculated what the diffs are, we need to figure out what the antinodes are. So we need to subtract from the left point and add on to the right point in order to find the antinode. So one possibility is that we have overlapping antinodes that I ought to account for. So let's actually keep a list of antinodes as well. List of antinodes, which will be a hash set so that it deduplicates. A hash set new, good. And thinking about it, we don't actually need to store this diff. We can just say let diff equals left.diff right. I think this is copying. I want to give it a reference. Why are you upset? Oh yeah, that's fine. Okay, so we want to insert into antinodes, insert left.subtract the diff and right.add the diff. However, we should only be counting these if they are within bounds. So let's I don't like this name, but I can't think of anything better off the top of my head. So let node 0 equals left.sub and if self, actually, if, yeah, it does need to be self. If self.inbounds node 0 and node 0, then insert it. The alternative being that we just add everything to antinodes and then filter it out, but I think that's less neat. Then we can do node 0 here, and that is that. Repeat this logic. Whoops. Except it will be right.add, and the name will be node 1. It doesn't need to be different, but I think it makes more sense if it is. Okay, so with that, we don't need to track the count. We can just take the count, take the length of the antinodes list, hash set. So at that point, we should just be able to do antinodes.length, which returns, yeah, our function doesn't return anything yet. So let's return a usize. This is so far all fine. Let's create a map. Antenna map dot double colon from string puzzle dot unwrap. Then assert equals. This will be our map dot part A. Let's run that test. Cargo test, not tet. And it's okay. I'm a little bit surprised because you normally expect something to go wrong, but let's test it against a larger test set. So we're going to run it against the full test text. Full test text. And here I believe we're expecting the result to be 14, but let's double check that. 14, correct. So let's cargo test. Failed, excellent. So we've done something wrong. Let's print out all the antinodes. Okay. And we've got 7, 7, 3, 4, 5, 6, 7. 7, 7. That doesn't seem right. Oh, 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Yeah, that is right. Okay. 0, 11. 13, 12. Interesting. I want to know what I'm missing, so I'm very quickly going to print out all of the nodes that are in this. Okay. Do something very ugly where I copy all of this. This should be antenna map results. We don't need a second one of these. Results. And then we add another entry, which is a hash. We want let mute antinodes is vec. And then we're going to antinodes.insert, push point row index column index. Now by doing this, it doesn't like that. Oh yeah, that's fine. Antinodes. And I need to return an anti-map results. Is that okay? Needs a comma. That is still not okay because we need to convert to i32. Okay. As i32. Great. All right. So now in my test, I can do let results equals antennae map results from str puzzle dot unwrap, but it won't be puzzle. It'll be results. Include str dot slash puzzle test results dot text. And then we are going to assert equals that results dot antinodes. Actually, we don't return them. So we're not going to do that. We are actually just going to print them out. Print line results antinodes results. Was that quicker than checking it by hand? I'm not sure, but I've done it now. Okay, so antennae 0, antinodes nothing. That's a bit odd. Because I need to take it from results. There we go. That's better. All right. Let's take our antinodes list, which is 06 down to here. So I'm just going to put that there and then take this and put it here. Now let's deduplicate it. Do we have 1, 3? We do. Delete. Do we have 3, 2? We do. Delete. Do we have 6, 3? We do. Delete. 2, 10. Delete. 0, 11. Delete. 10, 10. Delete. 11, 10. Also delete. 4, 9. Delete. 5, 1. Delete. 13, 12. No. No, that's not there. Okay, so that's where I've got one too many. We can carry on doing this. And I'm not sure why this comes out the same. 7, 0, 13, 12. Okay, so this is probably a bounds checking issue where In fact, we can just print out the whole of the structure and check by hand that it's the right size. So let's do that. Tests. Give me my map. Run it again. And then my test has I can't see the width or the height on this. Width 12, height 12. So why is it allowing a point that is 1312? It shouldn't be. So that's my bounds checking wrong. So yeah, this is 12 lines and this is 12 characters. So yeah, I'm storing the width correctly, but I am bounds checking it incorrectly. So that's what's going wrong. All right, let's check. Seem to want to iterate on a map's values. That is true, I do. Let's get rid of that. No need to store the frequency. Okay. Okay, so my inbounds. Point at 0 greater than or equal to 0. Point at 1 greater than or equal to 1. Point 0 is less than self.height. Self.height is stored correctly, right? So point 0 should be a maximum of 11, because if it's 12, then it fails this check. Oh, I'm bounds checking the wrong node. Okay, that makes sense. So that now passes. Let's test it against the full run before deleting all the helpful extras. Create a new file, input.txt, save that, and then create our main function. At last. Let puzzle is include string puzzle input.txt. Let our map be an antenna map dot double colon from str puzzle. And again, there's no way this can error because we don't have a return error at all. So we're just going to unwrap this. Then we're going to print line part A, and then format it with map.part A. Okay, let's cargo run this. Cargo run. Great, 220. And once I check this is correct, I'll remove all the debug print statements. Go. That's the right answer. Excellent. Let's take out some print lines. We don't need this results set anymore. We don't need these print lines. That should be good. We can delete this test results. Yes, we can delete antenna map results and the entire from str implementation. Let's delete that. Oops. Format and delete another print statement. Yeah, here, right. So now if I run it, it should just give me the right answer with no extra guff. Yeah. Great, so that was, I had the bounds checking logic correctly, but I was checking 2 points, or I should have been checking 2 points, but instead I checked the first point both times and didn't check the bounds for the second point. So that's why that was wrong. Let's continue to part 2. And again, I'm going to read over this and then explain the puzzle once I understand it. Okay, so I'm actually kind of pleased because how I misunderstood the first part of the puzzle is what part 2 is. So earlier when I was explaining and I said, I've already misunderstood the puzzle, I expected the antinodes to continue in a diagonal line. That's what part 2 is. It doesn't stop one pole away, it continues in a line throughout the whole map. And what's better is that I think it's fairly easy to adapt our code to this. So let's take our part B. Let's create a test text for it first. Test text. This will be part B. This will be part A. This will be 34. And we can even copy this. Test small text, part A. Test small text, part B, because our small text has an extra line to account for this missing node. So we should now get 3 antinodes from test small.text. So it is useful to know that in a tiny example it works, and a normal size example it doesn't, for example. Okay, let's implement part B. Part B. And self returns a use size, the same signature. I'm even just going to copy this code minus this comment that is not that useful. Except at this point, instead of these if statements, I'm going to do let mute node is left.diff right. Oh, sorry, no, we've already got the diff. So left.sub node while self.inbounds and node insert node equals node.sub node. Consider borrowing here, borrow. Consider borrowing here, borrow. Oh no, this will be diff, which is a great point because it also ought to be diff here. Diff. With 2 Fs, not 3. Okay. Now we're going to repeat this for the right.add and diff. And again, we add instead of subtract. Okay, let's cargo test that. Failed on both counts. Because we are still calling part A on both of them. Test again. Failed. But our small test passed. We've got 5 fewer nodes than we should. I think this line is the key to why I've got it wrong. It includes the antinodes that appear on every antenna. So the reason my small test worked is because I said the puzzle should be an answer of 3. In fact, it should be an answer of 5. Now, I can check this by changing my expected result and also starting with left and right as the answers. Okay. Can't do this, but we can borrow. Apparently it's happy with that. No. Temporary value dropped while borrowed. Okay. There's a simpler way to do this, and that is just to clone it. Node is node.clone. Now we don't need to borrow it while we're doing a sub. And that's really what we wanted to do anyway, is clone it. Left.clone, it doesn't like it because try dereferencing it. Okay, so instead of .clone, we just do star left. So it's like, make this node the contents of left, or make this node the contents of right, which is explicitly telling it to copy it. Let's run this test again. All test results okay. So that's what it was. It's because it draws a line across the map, including the two antennae that the signal is coming from. Let's print line. And update the function that is being called, and then cargo run. We get a result. Let's see if it's correct. Oops, I think it was 813. Although I'll double check that because it locks you out for a minute if you don't put that in right. That's the right answer. So there we have it. Day 8 is solved. Now, I do have quite a lot of time left. I would like to go back and quickly try and turn these into the functional style iterators instead of using as many for loops. I think it's good practice on top of everything else. So I'm going to spend a couple of minutes doing that before I end the video for today. So let's go back into the code. So first I want to save the height as puzzle.lines.length as I32. Let width is puzzle.lines.first. Can I take the first? No. Nth 0.unwrap as I32. Now I did this in another puzzle recently. Count. Yeah. Yeah, I did this in another puzzle recently, and this turned out to be wrong. The wrong way of doing it. It gave me the wrong result. I'm not sure why not. I would like to understand it. So I'm using this opportunity to try it out. That worked. So I don't know how I did it wrong before, but it seems to be working just fine now. I can even do a cargo run and check I get the same results. 220 and 813. Yeah, that's the same. Okay, so we've calculated the size of the map. Now we're going to do a more of an inline initialization of this hash map. So we can do a puzzle.lines.enumerate. And it's going to, for each. I'm not sure we really need to functionalize this anymore. I think it doesn't really add anything. So I am going to leave this as it is, but for part A and part B, I think it'd be possible to push it into a state that's a little bit easier for us to understand and for the compiler to optimize away. Let's give it a go quickly. So self.antennae.values. Then we're going to map that row to a count of how many that gives. Although realistically, we do want to store it in a hash set. So this is fine. So let's, for each, this will be left index and left. We actually need this to enumerate. Then we're going to do we do want it across the current set. So yeah, I'm not sure, again, that making this a functional style adds anything. We could try and make this into some kind of a loop where we remember that we sub on one side of the loop and add on the other. But as there's only two cases, again, I think it doesn't really add anything. So yeah, I think having read over the code again, I tend to try and make it functional, but I'm not going to force it to be functional for the sake of it. I think it's well readable in its current state. So if you have any ideas of how to make this neater or how to make it functional and some advantages for doing so, please leave this in a comment. I do read all the comments. I'll happily take your feedback. Otherwise, I'm going to leave day 8 here, solve successfully, and I'll see you tomorrow for day 9. Thank you for watching.